Hi everyone. We are at the Fundamentals of Microscopy format for the lab and the activities for the lab. I want to go over it with you a bit so that the report sheet seems easier to encounter and you're able to do the entire lab successfully. There are a number of activities in this lab. I believe there are 9, and it's going to take a while to get through. Please plan time to do this. Do not try to attempt this in one day. And you are going to be using some of the prep work that you've done on your moldy bread and your brined shrimp. This lab will also require some practice and technique. Biology is all about technique. So I hope that you're able to practice for a few hours and then do the lab. And I hope that you will plan for that. So we have mentioned what's in your microscopy box, and we have mentioned some of the additional materials that you'll need, like batteries and a Phillips head screwdriver. And now we are going through and looking at the activities in the lab itself. And I'll pull this out a little bit so you have a little bit more room to see everything. There you go. With each procedure, read the directions beforehand, please, and then put all of your answers into the report sheet located in Blackboard. If you decide to use photographs for your microscopy work, those photographs should be pasted into the document in the activity page that you have there so that I'm able to see that. If you could label them, that would be lovely and really help me to help you more easily. When you're all done pasting this in, or if you'd rather draw in your view of what you see through your microscope, that's completely fine. Then you can either take good photographs of your drawings or you can scan it. If you do take good photographs, you can make them even better and look even more professional by using an app called Microsoft Lens. And loading everything into Microsoft Lens will adjust the color of the background and really make the print more sharp, and it will scale your page to size as well. So it'll really look very professional. I want you to find the tools that you need in order to make your work look very professional. Let's get on to activity 1, which is a writing activity that you will need to do research on. You'll need to research the function of these different types of microscopes. This work is not in the investigations manual, not in the user manual. You might get a bit from the investigations manual on stereo microscopes. But I really trust that you're going to need to do some Google searches on these to look at the specific functions of them so that you feel comfortable. If you are pursuing a study, you feel comfortable knowing the strengths and weaknesses of these microscopes as you've annotated them on your report sheet. Then for activity 2, you'll start working on your microscopy skills. You are going to be using the prepared slide, which is in your box of slides. The first one is of wool, and you can see the wool on the slide with the naked eye. And you'll be able to locate where you want your objectives to look in on the slide, so you'll know where you need to put your wool in order to be over the aperture on the stage and to sit it there for your objectives to look over it. Make sure that your 10 times eyepiece is in place. Then turn on the lower light for compound viewing, and you will work with the 4x objective lens first and focus it, and then draw or paint with Microsoft Paint or Paintbrush or Cami, or take a photograph of what you're seeing with the 4x objective. There is, and I'll remind you of this, in the investigations manual, a link to a great tutorial on photographing through the lens. It is not easy, and it's going to take some time and practice for you to get it right. The photography won't be saving you too much time on this lab, perhaps, because it takes some real patience and technique to get it right. So you decide what works for you. You have a lot of options there. After you look at 4x, which when you multiply it by the eyepiece of 10x, you've got 40 times right there. You'll be turning in the 10x objective and getting a better look at it at the wall, and then rotate it to the 40x objective and do the same drawing or insertion or photography with the 40x objective in place. When you are looking at the 40x objective times the 10x eyepiece, you have 400 times magnitude. I think the microscope does a good job there, and I hope that you will too. Your report sheet will have circles available for you to draw in what you see, or you can please put the photograph over that area, or you can paint into that area. The more detail you put in, the more your memory locks it in, the better it will be for you on quizzes, and the better that you will remember what you're seeing in terms of cellular components that you'll need to know in your lecture as well. Activity 3, do the same things with the onion bulb epidermis prepared slide. You're going to be using the compound lens, you're going to be using the compound light, which is the bottom light for that. You're going to be looking at the 4x always first, focusing it and drawing or getting a graphic of that, of what you see of the onion, and then looking at 10x, comparing it, taking a look at it, and then looking at 40x. And again, you're going to be recording what you see. And you should be able to label cytoplasm, nuclear, cell wall on 1 or 2 cells in your image, especially in your 40x. You might even see a bit in your 4x as well, if you're very observant. For activity 4, you're using your third prepared slide. The third prepared slide is of frog blood, and you may be smart to do a little research before you look at this slide. And the research that you would do is to research what white blood cells and red blood cells look like for frog blood. I don't think you can assume that the red blood cell is red and the white blood cell is white. And it might do you some real good to take a look at what those cells look like and research that a bit. Again, you're going to be looking at the 4x, then the 10x, then the 40x. You're only drawing in the 400 magnification here, and you're answering questions from your research about platelets that frogs have. And it's always great to put in a paragraph. And when I say put in a paragraph, I always talk about the 5-sentence paragraph. And the 5-sentence paragraph that really works well for everything that you write, and particularly for scientific writing, is a paragraph that has an introductory sentence and a concluding sentence. And in between, it has 3 pieces of evidence. That can be data, that can be scientific laws, that can be scientific theories. It provides data and facts that support your introductory and your concluding sentence in that paragraph. So a quick way to remember that is to always think, sentence 1, tell them what you're going to tell them. Sentence 2, 3, and 4, tell them, tell them, tell them. And sentence 5, concluding, tell them what you just told them. If you stick with that format, you will really make your scientific writing clear and concise and that will help you to cement this into your head so that you can respond really well and learn a lot faster. So that is your lab on frog blood cells. Then you are going to get into preparing your own cells. Preparing your own cells, I'm going to put that on the next video. So join me back here and I'll see you then.